Good day everyone, I'm Sir RJ Layson, your math tutor and guide on this exciting journey through the world of numbers. In this video, we will discuss all about addition and subtraction of radicals. Now, before we proceed to the examples in adding and subtracting radicals, we will now identify first what are the like radicals and unlike radicals. So when you say like radicals, they have the same index and same radicand. For example, we have here 3 square root of 5 and negative 8 square root of 5. So they have the same index 2 and the same radicand 5. Next, we have 4 square root of y and negative 5 square root of y. So they have the same index also 2 and then same radicand y. 2y, 4th root of 3xz, and negative 5y, 4th root of 3xz. So they have the same index, 4 and 4, and the same radicand, 3xz, 3xz. Next, we have 5a cube root of 5bc and 7a cube root of 5bc. Next, we have the unlike radicals. So what are the unlike radicals? They have the same index and different radicand, or different index and same radicand. So we have here example, we have 4 square root of 2 and negative 2 square root of 7. They have the same index but they have different radicand. So we have 2 radicand here and we have 7 radicand here. So we have here next 12 square root of x and 10 square root of y. So they have the same index 2 but different radicand. So we have here x and then here y. Okay, next example, we have y, 4th root of 3z and negative 5 cube root of 3z. So they have different index. We have 4 and 3 but they have the same radicand, 3z and 3z. Next, we have square root of 5 and cube root of 5. They have different index. We have squared, 2 here and 3, and then, but they have the same radicand, 5 and 5. Now, let's proceed and simplify by adding and subtracting radicals. So, for example, we have here 5 square root of 2 minus 3 square root of 2 plus 2 square root of 2. You look at the index and the radicand, so they have the same, so that means they are like radicals. So since you have like radicals class, you can just add and subtract the whole number there. So we have here 5 minus 3 plus 2, since they have the same radical or like radical man sila, so you just need to copy square root of 2. 5 minus 3, we have 2. 2 plus 2, we have 4. So we have 4 square root of 2. Next example, we have 10 square root of x minus 13 square root of x plus square root of x. Since they have the like radicals class square root of x, you just need to add and subtract the whole numbers. We have 10 minus 13 plus 1, copy square root of x. We have 10 minus 3, we have negative 3, plus 1, we have negative 2 square root of x. Example number 3, we have 8 square root of 5y minus 5 square root of y plus 3 square root of 5y plus 2 square root of y. Now, you look at the index, so they have the same index but different radicand. So we have here 5y, we have y, we have 5y and y. So all you need to do, class, is you just need to combine the like indices and like radicand. So we just need to combine, operate 8 square root of 5y plus 3 square root of 5y, and then plus negative 5 square root of y plus 2 square root of y. So we have here 8 plus 3, since we have the same index and then we have the same radicand. So we have square root of 5y, so 8 plus 3 there, square root of 5y, plus you also combine the same index and radicand or like radicals. So we have here square root of y, so we have negative 5 plus 2 square root of y. So simplify, so we have 8 plus 3, we have 11 square root of 5y, negative 5 plus 2, we have negative 3 square root of y. So the final answer is 11 square root of 5y minus 3 square root of y. Next example, we have square root of 5 plus 2 square root of 5 minus square root of 5 plus square root of 45. Now you look at the index and the radicand. So this three of them, square root of 5 plus 2 square root of 5 minus square root of 5, they have the same index and radicand. But here in the last term, we have square root of 45 there. So all you need to do, class, is we just need to factor this one, which is, to simplify this one, we need to factor this one, which one of the term there is a perfect square and the other one is a non-perfect square. So simplify this one, class, because they have the same index and radicand. They are like radicals. So we have here 1, we have 1 here, plus 2, minus, we have 1 also here, square root of 5, plus square root of 45. So we have here 1 plus 2, we have 3 minus 1, we have 2 square root of 5 plus square root of 45. So we just need to factor. What is the factor of 45? One of them is a perfect square. We have 9 times 5, that is 45. Since square root of 9, class, is a perfect square, we can simplify that one. So we have 2 square root of 5 plus 3 square root of 5. So since they have the same index and radicand now, so you can add this one na, class. So 2 square root of 5 plus 3 square root of 5, we have 5 square root of 5. Example number 5, we have 5 square root of 54 plus 2 square root of 24 minus 2 square root of 180 minus 5 square root of 20. Now, class, they have the same index, but they have different radicand, class. So they are unlike radicals. So all you need to do, class, is to factor each of the radical there, and then until they end up into the same radicand. So if they will not end up in the same radicand, class, so just be it, class. So let's try this example. What is the factor of 54? So we have 9 times 6, since 9 is a perfect square, plus 2. What is the factor of 24? We have 4 times 6, since 4 is a perfect square. Minus 2, what is the factor of 180? We have square root of 36 times 5, since 36 is a perfect square. Minus 5 square root of 20, we can factor square root of 20 as square root of 4 times 5, since 4 is a perfect square. Now, simplify the mga terms sa radicand, class, so that like for example, here we have square root of 9, we have 3, so we have here now 5 times 3 square root of 6. Square root of 4 is 2, so we have here 2 times 2 square root of 6. Simplify square root of 36, we have 2 times 6 square root of 5. Square root of 4 is 2, so we have 5 times 2 square root of 5. So 5 times 3, we have 15 square root of 6, plus 2 times 2, we have 4 square root of 6, minus 2 times 6, we have 12 square root of 5. Negative 5 times 2, we have negative 10 square root of 5. Now, you just need to combine or operate the same index and same radicand, class. 15 square root of 6 plus 4 square root of 6, we have here 19 square root of 6, minus 12 minus 10 square root of 5. So 12 minus 10, we have 2. Since the operation here is subtraction, we have here 19 square root of 6 minus 2 square root of 5. That is the final answer. Next, we have 15 square root of 200 plus 7 square root of 50 minus square root of 2 square root of 80. So all you need to do again here is you just need to factor the unlike radicals, the radicand, factor the radicand here until you will get the same class radicand. So when you factor a certain value in the radicand, class, all you need to do, all you need to remember that one of the term there must be a perfect square and the other one is a non-perfect square. So we have 15 square root of 100 times 2 plus 7, the factor of 50, we have 25 times 2 minus 2 square root of 18, we have 9 times 2, class. So we have to simplify this one. So we have here 15 times square root of 100 is 10. square root of 2 plus 7, square root of 25, we have 5, square root of 2 minus 2 times square root of 9, that is 3, square root of 2. So we have here the same index and same radicand now. So simplify first the whole numbers. So we have 15 times 10, we have 150 square root of 2, plus 7 times 5, we have 35 square root of 2, minus 2 times 3, we have 6 square root of 2. So operate this one, 150 plus 35, 185 minus 6, we have 179 square root of 2. That is your final answer. We have here next 10z square root of 18z plus 6 square root of 98z cubed. Now, we have here unlike radicals again. So, you just need to factor the radicand. So, we have here 10z square root of 9 times 2z plus 6 49z squared times 2z. So, simplify the perfect square there. So, we have here 10z squared of 9, we have 3, 10z times 3. The remaining are in the radicand, we have 2z squared of 2z plus 6 times square root of 49 is 7, square root of z squared is z. So, 6 times 7z square root of 2z. So, simplify here the terms outside the radicand. We have 10z times 3, we have 30z square root of 2z plus 6 times 7z, we have 42z square root of z. Since we have the same radical class, like radicals man sila, all you need to do is you just need to simplify the terms there now since they have the same radical. So we have 30z plus 42z square root of z, we have 72z square root of z. Example number 8, we have here now square root of 18 plus square root of 1/2. Now, we have here a rational exponent na or rational expression. So, again, in simplifying denominators, radicals with the denominators class, we need to use rationalization. So, we have here, we can factor square root of 18 as square root of 9 times 2 plus square root of 1 over square root of 2. Since our denominator is a radical class, all you need to do is we need to use rationalization. You multiply both numerator and denominator by square root of 2. So, we have here square root of 9. We have 3 square root of 2 plus square root of 1 times square root of 2. We have square root of 2. Square root of 2 times square root of 2. We have square root of 2 squared. Simplify this one. We have 3 square root of 2 plus square root of 2 over. We can cancel the square root and the exponent. So, we have 2 here. To simplify this one class, you change the exponent here, the denominator here into 2 also. So, how man? So, you just need to, what is ano class? The numerator will become 6 now since 6 divided 2 is 3. So, they have the same denominator now. So, your final answer, you can simplify by adding the numerators term class since we have the same like radicals naman sila. So, we have 6 square root of 2 plus square root of 2. We have 1 here. So, 6 plus 1, we have 7 square root of 2 over 2. Example number 9. So, we have 2 square root of 12 minus square root of 1/3. Again, we will use rationalization in here. So, 2 square root of 2 minus square root of 1 over square root of 3. So, we have 2 square root of 4 times 3. Since we can factor 12 into 4 times 3, 4 times 3 is 12. So, since 4 is a perfect square, we can simplify that one later. And then, we have here the rational expression. So, square root of 1 over square root of 3. Use rationalization. So, multiply both sides by square root of 3. So, we have here, square root of 4 now is 2 times 2, square root of 3. Minus square root of 3 over square root of 3 squared. Simplify this one, we have 4 square root of 3 minus square root of 3 over 3. So, change here, to simplify this one, we must have the same denominator in this one. So, dapat 3 din ang denominator niya dyan. So, we have here 12 square root of 3 minus square root of 3 over 3. So, the numerator now will become 3 since 12 divided 3 is 4. So, now we have 12 square root of 3 minus square root of 3. We have 1 there. We have 11 square root of 3 over 3. Last example, we have square root of 80 over y raised to 10 plus square root of 81 over y raised to 10. So, in simplifying this one class, so you just need to factor the terms that have perfect square and non-perfect square terms. So, we have here 80 is square root of 16 times 5 since square root of 16 is a perfect square. And then, simplify na din class the denominator. So, first, in the numerator, square root of 16, we have 4 times, we have now 4 square root of 5. Square root of 81 is 9. Square root of y raised to 10, so we can divide 10, divide 2, so we have here y square root raised to 5. Plus, square root of 81 is 9, and then the denominator, we have square root of y raised to 10, again 10, the exponent divide the index, so we have y raised to 5. So we have the final answer now, 4 square root of 5 plus 9 over y square root of 5. Again, thank you so much for watching class. I hope that you've learned something out of this lesson. So please don't forget to like and subscribe. And if you have questions, you can comment down. Thank you everyone and God bless. Goodbye.